Okay, click and close, have a look.
What, that was a work day?
No, tomorrow.
What?
Tomorrow. Yeah. You guys are gonna, I'm gonna do, it'd be better for you guys, you're ready for it, so I'm gonna do stuff today and some work tomorrow, and it'd be better, you'd rather have it tomorrow, trust me. So I wanna look at a couple things. I wanna look at, well, actually just one concept. I wanna look at fitting a function to data. Okay, so if we know, for example, and I'm gonna go back and use an example we've already done. So we know, for example, that if we've got a line that has to go through those 2 points, you guys can all tell me what the equation of that line is, right? So we're gonna match it to probably what form? Slope-intercept, right? So we're gonna match it to the form y equals mx plus b. How many unknowns are there in that equation, the slope-intercept form? Or how many parameters are there, I should say? How many numbers do I have to be able to plug in to specify the line? 2, m and b, right? Slope and y-intercept, okay? Well, slope is essentially given to us, right? We can calculate that from the points. So the slope, m, is, you fill in the blanks. What minus what over what minus what? Say it again. Okay, so what are those? Just give me numbers. -10 minus -6 over. Okay, so what's that give us? -10 minus -6 is -4. 2 minus -6 is 8. So that gives us -1/2. So there's m, right? Partway there. Okay, you guys click those all the way close. I want you watching this too, because this is something, you guys are going to have questions on this if you don't watch it, I promise you. So we know m, how are we going to find b? It's the y-intercept, but they don't give us the y-intercept. Essentially, they gave us the slope, didn't they? Right? They gave us information that allowed us to quickly calculate the slope. But we can't directly calculate b from the points that we get, right? Okay, but here's the concept I want to drive home here. We talked about this earlier. This becomes important again. We know that both of these 2 points are on the line, and so they are both solutions, right? Remember what it means to be a solution. To be a solution of an equation, it means that you satisfy the equation. Each of those points represents ordered pairs, x and y values, that make the equation true, guaranteed, right? Well, that's more work than we need to do. If we want to solve for b, like right now, if I plug that m in, don't I end up with y equals -1/2 x plus b, right? B is the only unknown, right? So I could use either one of those solutions because I know there are values of x and y that work. I could plug in values of x and y that I know have to work, and then the only unknown that's left over will be b. That's fine. If I have an equation with only a single unknown in it, I can solve for that unknown, right? So we could, for example, plug -6 and -6 in, right? If I plug -6 in for y and -6 in for x, I get -6 equals -1/2 times -6 plus b. Well, I can solve that for b, right? I just simplify first. -1/2 times -6 is 3. Oops. And then all I've got to do now is just subtract 3, right?
So it's negative.
So b equals -9. Well, now I've got everything I need to write my line. There's my m. There's my b. Right? You get the idea, okay? So what about something like this then? So this is just kind of the next logical step. So okay, what am I given here? They give me 3 points. Now look, we're starting off with a function that's in factored form, right? Or intercept. Sometimes it's called factored form, sometimes we call it intercepts form because it's giving me the x-intercepts, isn't it? Right? So A stands for the vertical dilation factor, P and Q stand for the x-intercepts. Look at the 3 points they gave us. Did they give us any of the parameters?
Well, it gave us,
See, he gave us X.
with the intercept there.
Oh, it gave us the x-intercepts, didn't it? Right, because look, that's the point -5, 0. When y is 0, we're on the x-axis, right? Everybody with me?
Yeah.
Okay, so then this is telling me right here that p equals -5. And this one right here is telling me that q equals 7, right? We got 2 out of the 3 taken care of. Now we're in great shape, because if I've got 2 of the 3 taken care of, then the only one I have remaining to solve for is A, right? All I need is a solution to plug in for x and y so I could solve for A. Do I have that? Well, all 3 of those are solutions, but I've already used those 2 points, right? This is a different one, though. I have a third solution right there that I can use that's going to allow me to solve for A then, right? So I want you to see how this works. So if I plug these guys in, I'm just going to get f of x, which is just y, isn't it? Right? F of x, I'm going to write it as y. Y equals A times x minus -5. Well, that's just x plus 5, right? So that's where we use that one, times x minus 7, right? So that's where we use that one. But now I got to solve for A. If I try to plug in -5, it's not going to work, is it? If I plug in -5 for x and 0 for y, look what would happen. I would get 0 equals A times -5 plus 5 is 0 times, well, who cares? 0 equals 0, right? So do you get that? These have already been used up. I already used those points to determine what P and Q were, right? Now I've got to use the other point to solve for A, right? So what if I do that? What if I plug in 13 for x and 54 for y? That's a solution, right? Well, look what happens then. I end up getting 54 equals A times 13 plus 5. What's that? 18 times 13 minus 7. I'm plugging, because that's 13 right there, right? I'm plugging 13 in for x. Maybe I better show that. Right? Well, that's just 18. And that's just 6, right? Agreed? Okay, so I could either multiply 18 times 6 and divide that, or if I want to, I could even just do this, right? I could even just divide each side by 18 and cancel that one. And so that's going to give me 3 equals A times 6, divide by 6. And I get A equals 1/2, right? Same deal, right? I needed to fill in one unknown parameter, and so I used my other solution for that, right? Now, if I just take all that stuff and combine it, look what I get, right? So if I combine those two things with that thing, I get f of x equals A times x minus P times x minus Q. And I'm done. How about here? You only gave me 2 points. It's enough this time, though. Right, because one of those points is special.
If it's back, then we always need to have 3 points. We're trying to.
Yes.
get it back.
Yeah, you would. I only need 2 here, only because it's kind of a trick, right? What are the coordinates of the vertex? I mean, they're -5 and 16, but which values, if this is written in vertex form, in terms of h and k and a, what does this tell me? H and k, right? So the vertex has coordinates h, k. So it's telling me h is -5 and k is 16. So I've accounted for 2 of those 3, which means I've still got to find a, but I've got another point that's a solution that allows me to solve for a, right? It's the same idea, isn't it, right? So we get, if I just plug this stuff in, I'm going to get y equals a times x minus -5 squared plus k, which is 16. I've only got one more thing to solve for, and that's a, and that's where I can plug in -13 for x. Whoops. I can plug in -13 for x and -48 for y, just solve for a, right? Giving me -48 equals a times -13 plus 5 squared plus 16. -13 plus 5 is just -8, right? -8 squared is, come on now, 64. So I'm getting 64a plus 16 equals -48. What are the 2 steps to get a by itself? Subtract 16. So I get -64 equals 64a, last step. Divide by 64, and a equals -1, right? So now we got everything we need. We got h and k, and we got a, and so the answer is f of x equals -1 times x minus -5 squared plus k, right? Get that? Okay, so that's doing it algebraically. There's a trick I'm going to show you that's a phenomenal trick you can use Desmos for. Now you got to be able to do it both ways, but there's a way you can do this on Desmos that's really handy. You know, maybe I should stop there.
Yeah.
Can you stop
Let
when
it
you
soak-
get to, when you get
let
to
it
the trick
soak it
part?
in.
Well, because you got to be able to do it the algebraic way. So maybe I'll have you do it the algebraic way first,
Yeah,
and I'll
but
show you the
it's-
trick tomorrow.
Yeah, but it's